first of 3 CH-47F Block II development aircraft nearing completion. June 29, 2018. Edited by Eric Brothers Boeing and the U.S. Army celebrated a major CH-47F Block II program milestone with the loading of the first Engineering and Manufacturing Development (EMD) helicopter into final assembly on June 27, 2018. The CH-47F Block II represents tomorrow's heavy lift readiness for the United States Army and her allied partners, said Col. Greg Fortier, U.S. Army Project Manager for Cargo Helicopters. Whether it is increasing total payload, improving the transmission, advancing the Chinook rotor blade, or setting the conditions for supervised autonomous flight, this aircraft provides ground tactical commanders immense capability to win in the multi-domain battle. The contract to develop the next-generation Chinook for the U.S. Army Conventional and Special Operations Forces was awarded to Boeing in July 2017. The Block II program incorporates several upgrades to increase lift capability, including advanced Chinook rotor blades, an upgraded fuselage, new fuel system, and new drivetrain. These updates greatly increase the commonality between U.S. Army and Allied fleets, thus reducing maintenance costs. Our progress from contract award to final assembly in less than a year is a direct result of the efficiency and reliability of the program, said Chuck DeBundo, Vice President, Boeing Cargo Helicopters and H-47 Program Manager. Block II upgrades will help keep Chinooks in operation for the U.S. Army into the 2060s. The first Block II aircraft is expected to be completed in 2019, with flight testing scheduled shortly thereafter. First delivery is expected in 2023. Eventually, the Army will upgrade more than 500 Chinooks to the new configuration. Learn about how correlating information throughout the process chain significantly improves overall part performance. June 29, 2018. Edited by Michelle Jacobson. Plan to attend the IMTS 2018 conferences to gain deeper insights into new manufacturing technologies and ideas about the topic. Since the first pioneering companies have been able to shape metal powders by means of 3D printing or melting, more companies want to supplement their conventional production processes with additive methods. How quickly and comprehensively additive manufacturing (AM) of metal parts will be established depends, to a large extent, on the yield. The 3D printing industry is far from guaranteeing the high reproducibility and reliability known from traditional manufacturing processes. AM has only a fraction of the combined know-how of conventional subtractive methods. Therefore, it requires a lot of investigation within every step of the process chain to enable optimal part printing. Gaining this process knowledge might take several years, but the number of iteration loops can be significantly reduced with detailed analysis of materials and processes. It takes significant experience combined with unique technology to allow for a deeper understanding and detailed monitoring of most process steps, such as material powder characterization, i.e., powder size, form, as well as distribution and compactness analysis, crystallographic analysis, build defects, internal and external surface analysis, internal and external dimensional analysis, and the influence of post-build treatments, such as heat treatment. Each step can have a significant impact on the overall yield. Therefore, correlating information throughout the process significantly improves overall part performance and reduces optimal recipe development time. Registration is now open, so check out the IMTS 2018 website for more information. Meet your presenter. Drive, March and B. Bauza is responsible for new technology and innovation of the Zeiss industrial metrology business and leads global additive manufacturing efforts within the research. He received his Ph.D. in mechanical engineering from the University of North Carolina in Charlotte and has his executive MBA with concentration on strategy from Duke University. Before joining Zeiss, he co-founded a startup, focusing on advanced motion and sensing solutions, and was focused on technology and business development. He has been awarded with numerous patents, wrote more than 30 publications, and serves as reviewer for precision engineering, wear, and measurement. Bauza also served as director and board member of ASP and was actively involved at ASPE since 2002. He is also member of ASME and CIRP. Jerry Rex named President and CEO, Dale Hedberg promoted to Vice President of Operations. June 28, 2018. Edited by Eric Brothers Precision Machine Tools and Automation Supplier Methods. Machine Tools Inc., Sudbury, Massachusetts, has made 2 key management appointments. Company President Jerry Rex has been named President and CEO, and Dale Hedberg has been promoted to Vice President of Operations. Rex has been President of Methods since April 2017 and prior to that, was Methods Chief Operating Officer. Methods is pleased to appoint Jerry as President and CEO. With his strong skill set, machine tool industry knowledge, and energetic management approach, we are looking forward to moving the company ahead through his continued leadership, positioning Methods as the industry's leading supplier of machine tool, technology and automation for our customers throughout North America, said Scott McIver, Methods chairman and third-generation owner. Rex has an extensive amount of machine tool industry and leadership experience, including hands-on manufacturing, engineering, sales, and executive management. He served for many years as a board member of AMT, the Association for Manufacturing Technology, and as chairman of the board of directors of AMT until April 1, 2016. He has carried the Certified Manufacturing Technology Sales Engineer (CMTSE) designation since 1997 and remains an active committee member. Spanning 40 years, Rex's manufacturing career began with a machinist position at GE Locomotive, and he steadily rose from roles in engineering and applications to production and sales management, and executive positions at manufacturers and machine tool organizations. Before joining Methods, he served as Executive Vice President of Concept Machine Tools, Minneapolis. Prior to that, Rex was president of Hegman Machinery LLC, a Morris Group company, from 2013 to 2015. For the 20 years prior, he held roles including president of Morris South Charlotte, North Carolina, vice president of Go-Seeger Inc., Dayton, Ohio, and regional manager of J. Methods. Dale Hedberg has been promoted from director, national product manager to vice president of operations. Hedberg is now responsible for all of Methods' operations including production, shipping, receiving, inside sales, trade shows, and continuous improvement. A machine tool industry veteran, Hedberg has been a Methods employee for nearly 20 years in engineering positions, and most recently as product manager for a high-performance CNC machining line. Prior to Methods, Hedberg was production manager at a tooling systems company for 10 years. Dale's proven skills for strategically managing Methods product lines and a deep knowledge of Methods infrastructure, as well as his extensive machine tool experience, made his promotion to Vice President of Operations a logical one, Rex said. He will play a key role on our management team. This type of grinding process reduces the cost and time required for production, thereby achieving efficiency in production. June 28, 2018. Edited by Michelle Jacobson. Plan to attend the IMTS 2018 conferences to gain deeper insights into new manufacturing technologies and ideas. About the topic, high-performance grinding, HPG, has been defined as any grinding process that enables higher material removal rates while achieving the same surface quality. 1. This type of grinding process effectively reduces the cost and time required for production, thereby achieving efficiency in production. HPG broadens the field of application of grinding from terminal, secondary finishing processes to include frontal, primary material removal process as well. Together with the technological advances of modern machine tools, innovative grinding wheels that consist of engineered, shaped abrasives and high-strength bonds provide the main driving force for HPG processes. Grinding with these abrasive wheels can achieve very high material removal rates (MRR) without impacting the quality and metallurgy of components made from difficult-to-machine materials such as nickel-based superalloys. Nickel-based superalloys, which constitute greater than 40% of the total weight of an aircraft engine, find applications in the combustor and turbine sections of the engine. Their use is primarily on account of the unique combination of high temperature strength, toughness and resistance to degradation in extreme environments. These properties also make them difficult to machine and render high-speed machining of components made from these superalloys almost impractical. Only specific abrasive wheels that remove stock at low threshold power forces and consume lower specific energy in grinding of these superalloys can survive the conflicting goals of higher productivity as well higher wheel life in an HPG process. Registration opens soon, so check out the IMTS 2018 website for more information. This presentation will focus on educating the attendee on each of the innovative features in modern grinding that enable HPG of nickel-based superalloys. Results and data from grinding's tests of IN 718, WASP alloy and other nickel-based superalloys will be presented. To compare and contrast, available data from machining of these superalloys will also be presented. Furthermore, data on the impact of change in coolant type oil versus water-soluble coolant on the HPG process will also be shown to emphasize the criticality of coolant. At the conclusion of this presentation, the attendees will have a deeper understanding of how HPG as a material removal process can play a major role in the roughing and finishing of components made from this important class of work materials in the aerospace industry. Reference SLAT, F. Barth, S. Matfeld, P. High Performance Grinding, Presidia, CIRP 46-2016-266-271. Meet your presenter. K. Philip Varghese has worked for Saint-Gobain Abrasive since 2011, leading the Advanced Application Engineering Team, Process Improvements, Customer Projects, International Team Training and Development, and Technology across Saint-Gobain's grinding technology centers. Prior to this, he worked as Chief Scientific Officer for CR Foundation, leading a team of scientists and engineers focusing on dental product and materials evaluation. He has a PhD in Mechanical Engineering from the University of Utah and an MS in Mechanical Engineering from the University of Michigan in Ann Arbor, Michigan. He has presented at numerous industry conferences and trade shows and has authored 23 technical papers and articles in the field of machining, dental products, materials, and grinding technology. First Block 70 aircraft for Bahrain to be built in Greenville, South Carolina. June 27, 2018. Edited by Eric Brothers. Artist's rendition of the F-16 Block 70 that will be built for the Kingdom of Bahrain at Lockheed Martin's facility in Greenville, South Carolina. Lockheed Martin received a $1.2 billion contract from the U.S. government to produce 16 new F-16 Block 70 aircraft for the Royal Bahraini Air Force. The award represents the first F-16 Block 70 sale and the first F-16 production program to be performed in Greenville, South Carolina. The Kingdom of Bahrain is the first customer to procure the F-16 Block 70, the newest and most advanced F-16 production configuration. We value our long-standing relationship with the Kingdom of Bahrain and look forward to beginning production activities on their first Block 70 aircraft at our facility in Greenville, said Susan Oustes, Vice President of Lockheed Martin's F-16 program. This sale highlights the significant, growing demand we see for new production F-16s around the globe. Lockheed Martin expects F-16 production to create between 150 and 200 new jobs in Greenville. F-16 production also supports hundreds of U.S.-based Lockheed Martin engineering, procurement, sustainment, and customer support jobs and thousands of U.S. supplier jobs. The F-16 supply chain is currently supported by 450 U.S. suppliers in 42 states. The F-16 Block 70 features advanced avionics, active electronically scanned array radar, a modernized cockpit, advanced weapons, conformal fuel tanks, an automatic ground collision avoidance system, an advanced engine, and extended structural service life of 12,000 hours. To date, 4,604 F-16s have been procured by 28 customers around the world. Approximately 3,000 operational F-16s are flying today with 25 leading air forces, including the U.S. Lockheed Martin Military Aviation,